So I went to Terry's team, all right, and I asked every single player, how old are you? How old are you? How old are you? How old are you? Okay, there were 17 13-year-olds, there were 14 14-year-olds, 6 15-year-olds, 9 16-year-olds, and 12 17-year-olds. That's a big lacrosse team, okay? Obviously, when I made this data up out of nowhere, I wasn't thinking rationally. But let's say I was looking at a college team, and even though their ages don't match up. Okay. So I have their ages, all right, and I have lacrosse players. And so I want to know, is there some correlation between the age of my lacrosse team, all right, and the number of players that are on there, okay? So the way I'm going to kind of analyze this is I'm going to figure out the line of best fit, okay? I'm going to see how they affect each other. Now, do you want to take these X's and these Y's? Do you want to find the rate of change for every single one of them and find the average and then figure that out at close to a close decimal? And then do you want to figure out the y-intercept? Yeah, I don't either. Okay, is it possible to find lines of best fit by hand? Sure. Do we want to do it by hand? No. All right. So where do we usually go when we need something done and we don't want to do it ourselves? Desmos. Okay. Yes, we are going to be in Desmos for a while. Okay, so everyone go ahead and snag Desmos, whether it's on your phone or on the computer. And I'm going there too. Hopefully by now you have the Desmos app because it's awesome. So you're either bringing it up on your Chromebook or you're bringing it up on your phone. Okay. So the first thing we want to do, and we'll try it in this order this time, Mr. McLaughlin, okay, is on my notes, I'm going to draw kind of a square here, and I'm going to write the word plus, or excuse me, I'm going to do the symbol plus, because I want to remind myself that that's what I'm going to hit in Desmos in order to put a table in there, okay? I want Desmos to know my X's and Y's. Okay, so on my screen, because I'm using the computery one, I don't know what it looks like on your phone, but hopefully similar. Just a plus.
Just a plus kind of in the middle of your screen on the left.
Okay, I'm going to click on that plus.
Click on it.
And what do you think I'm going to click on? A table. Nice. So you do the same. And we're going to tell Desmos the data. We're going to give them the X's and we're going to give them the Y's. Now, don't be scared that the table Desmos has is up and down. Okay, we're still able to do an up and down table even though we're given a side-to-side one. Okay, the X value in this particular instance are the ages. So let's go ahead and put those in. 13. 14. You can just hit enter. You see them?
The great thing about Desmos is you do the first two, you can just keep enter, all in a row.
Okay, now I'm going to put the number of lacrosse players that were that age. 17 of those, 14 of those, 6, 9, 12. Okay. So once we've given Desmos the data, we need to say, give me the line of best fit, all right? But you can't ask that of a computer. It doesn't understand, give me the line of best fit, all right? So instead, we're going to have to use its own language. So here's the way we tell Desmos to give us the line of best fit. Y sub 1 wiggle M X sub 1 plus B. Y1 wiggle MX1 plus B. Y1 wiggle MX1 plus B. Y1 wiggle MX1 plus B. Okay, looks pretty familiar, right? It's pretty close to what? I can't hear you. Your mama's ex-boyfriend, all right? It's pretty similar to your mama's ex-boyfriend. But Desmos needs to know that it's dealing with the X1s and Y1s, all right? And it also uses that little wiggle called a tilde, and I don't know why it needs that.
Oh, because it's approximated.
Okay, because it's approximated, okay? So y1 wiggle mx1 plus b, all right? So once we have that, we're going to go back to Desmos, and underneath the table, make this a little bit smaller. It's just another manic Monday. Go away. Okay, so underneath this, I'm going to go to a new row, and I'm going to do y1 tilde mx1 plus b. Okay, so when you are typing in Desmos, you can just do y1, and it immediately makes it that subscript.
Actually, it did it for you.
Huh?
It did it for you. Right away. You didn't have to type it.
What do you mean?
Once I did that, I just hit enter, it gave me.
You just hit enter?
Yes.
Oh,
You just hit enter.
does that work on the computer too?
I don't know.
Let's see. Enter.
Nope.
Ah.
It's on the phone. Did you guys do that? You hit enter? Yeah. When I hit, it just worked for you? Okay. So I just hit enter and it did that. So just FYI, so just in case it, for some of them, it pops up like that, we need to let them know. But keep going, so just in case it doesn't, they're gonna have to.
Right. Y1 wiggle mx1 plus b. And that is the Desmos computer way of saying Desmos. Could you give me the line of best fit based on these x's and these y's? Give me the slope and give me the y-intercept. Alrighty, so you'll notice that I'm not seeing any of these points or a line on my graph anyway. You can totally zoom out, zoom in. Desmos is nice like that, where you can take a look at the data, you can take a look at the line, and oh, look how pretty. But I'm not super interested in you drawing the situation. I'm interested in the equation, the line of best fit. So I'm going to move my eyeballs over to the left, and I see some interesting variables given to me here. I've got r squared, I've got r, I've got e sub 1, I've got an m and the b. Which one is interesting to us if we're writing an equation? The m and the b. That's what is of value to us right now, where we want the average rate of change and we want the y-intercept. Alrighty, so on my paper, I'm going to take the m that they give me, which is negative 1.5, right? I am really bad at memorizing. Negative 1.5 x plus, and in this case, it's a positive y-intercept, and what was it again?
34.
34.1. Now, you might notice in this case, Desmos gave you two decimals that were sort of rounded to the nearest what? You guys remember what place value that is when there's 1 to the right of the decimal? 10th, yeah, it's kind of, someone in first block was saying like, I don't remember how to round anything, okay? It won't always be rounded like that, all right? Rounding to the nearest thousandth is usually what is safe, but you never know what Desmos is going to give you, okay? So y equals negative 1.5x plus 34.1, that is our line of best fit.